So this week we're going to take a look at a few different topics, just kind of getting ready for MCAS. The first topic we're going to look at, and the only one that there's notes for, is on circles. Okay? So circles is a topic you may or may not have gotten to yet. That's why I wanted to give you guys a little bit of information about how you're doing. So when we talk about circles, there's a few different terms that come up. Okay? One of the terms is what's called exterior arc. Okay? All that an exterior arc is an arc is part of a circle. So like from here to there, what I just traced in black, that is called an arc. All right. Another term we're going to see come up is interior angle. Okay? Interior means it's on the inside. So those angles that I just numbered, 1, 2, 3, 4, those are all what we call interior angles because they're on the inside of the circle. And I think that's it. Those are the only two terms that are going to come up. All right. Whether you're dealing with the angles on the inside or the arcs on the outside, they always add up to 360 degrees. Okay? That's the key for solving all three of these problems. The angles on the inside and the arcs on the outside always add up to 360. All right. So let's look at the first one. Erase this. That arc that I just had, that was one of the arcs. How many arcs are there all together on the outside of this circle, if you were to trace all of them? 3. Yeah, there's 3 different arcs. There's this one. Do that one in black. There's this one in red. And there's this one in blue. Okay. So in this particular circle, there's 3. In other circles, there could be more or less. But that one has 3. And what did I just say that all 3 of those arcs have to add up to? 360. They have to add up to 360. Yep. So they want us to find that symbol right there means the measure of arc FG. That's how you name an arc. You just use 2 letters, FG. All right. Since we don't know arc FG right now, what could I temporarily call it? Since I don't know what it is. But what do we always call something that we don't know? We use a, yeah? Yeah, we use a variable. So for now, let's just call it x. All right, so there's 3 arcs on the outside, and we know that this one, plus that one, all has to add up to 360. Okay, so that's the equation you write down. Take the first one, plus the second one, plus the third one, and we know they all have to add up to 360. Right, and now we just have to solve the equation. When we combine like terms, what's 150 plus 120? 270. And now we've got one step left to solve for x, which is the size of that arc. How do we get that 270 on the other side?
Subtract it from 360.
Yep. So we're going to subtract it and subtract it. And that's gone. And then we can just type in 360 minus 270. Yeah, so if you don't have a calculator, you could just figure it out in your head. If you need a calculator, I'll get some out. But yeah, 360 minus 270, it's going to be 90. And make sure you put a label of degrees, okay, because that's how you measure the size of an arc. It's in degrees. That's it. Any question on that one? All right, let's look at the next one. So it says interior angles, and they want the measure of angle GFH. So if you're not sure where that is, then just trace from G to F to H. It's that angle right inside there. Okay. All right, they give us the other 3. There's 1, 2, 3. What did I say earlier that all the angles on the inside have to add up to? 360. It's exactly the same thing as the problem above. You don't do anything different. So we're going to write them all down, but we don't know angle 3. So what could I temporarily just call it?
X.
Yeah, we just call it x for now. So if you add the first angle plus the second angle plus the third angle, it doesn't matter the order you add them up in. You just have to write them all down, added together. Equals 360. Okay, let's add them up. What do you get when you add 80 and 120?
200.
That's 200 plus 60.
260.
260. So 260 plus something is going to give me 360. And how do we get the 260 on the other side?
Subtract.
Yep, you subtract it. If you subtract 260 on the left, it's gone. What's 360 minus 260?
100.
100. And there you go. That's the size of this angle on the inside, 100. Just make sure, well actually they already put the degree symbol on the box. So I guess you wouldn't have to type the degree symbol in if this was a problem on IXL. If they don't put the degree symbol on the box, then when you click inside it, they're probably going to make the degree symbol pop up as a button you could click. Any questions on that one? Let's try one more circle, and then we'll look at a different kind of question. It says solve for x. Okay. So this time, are we solving for something that has to do with an exterior arc or an interior angle? Yeah. Yeah, the x is on the exterior arc. Yep. So we're solving for something with that. And they give us how many exterior arcs in that picture? They give us 4. 1, 2, 3, 4. Okay. And we know that if we take all 4 of them and add them up, they're going to add up to how much?
360.
They're going to add up to 360. Okay, so that's the equation you need to set up. Fill in each exterior arc where I left a blank. Doesn't matter what order you do them in. So let's do x plus 53. The next one is x plus 32, x plus 63, and 59. Okay, so now on the left side, we've got a lot of like terms I can add up. Let's start with the x's. When I add all my x's together, how many x's do I have on the left side? 3. So it's going to give me 3x. And then I have other like terms I can combine that don't have an x. The 53, the 32, the 63, and the 59. So we can add all those up. 53, 32, 63, and 59. So that gives me 207. Okay, so I combined everything I circled in blue. All those get combined together. And then I combined everything that was circled in purple on the left side. Okay, what would be my next step to solve that equation for x? Yeah, Gigi?
Subtract 207.
Yep, we're going to subtract the 207 on each side. Okay, so 207 minus 207, that's gone. In this step, nothing happens to the 3x. That stays right where it is. And we've got 360 minus 207, 153. Okay, now that's not x, that's 3x. So what's my last step? Divide by 3. Yep. And the trick if you want to know if that's going to come out nice, if you add 1, 5, and 3 together, 1 plus 5 is 6, 6 plus 3 is 9. Because I added these numbers up and I got 9, 9 is divisible by 3, which means 153 is divisible by 3. So we're going to get a nice answer. Anybody know what 153 divided by 3 is? Yep. 51. Yep. Again, don't forget the degree symbol, but they already put it on the box, so you don't have to type it in. Okay. Any question on that? Okay. Okay, so the next IXL looks at totally different, nothing to do with circles. Looks at if a coordinate that they give you is a solution to this system of equations. How can I check if that coordinate, which has an x and a y value, works in those equations? What do I have to do with that coordinate?
Substitute.
Yeah, you substitute it in. What number, well, they're the same in this case, but what number are you going to substitute in for the x value?
X.
What number?
Oh, 6 and 8.
No. So what number are we going to change x to? Yep. 1. Yep. And what number are we going to change y to? Yep. It's also 1, just a coincidence, they're both the same. So fill in a 1 for x, a 1 for y, and you want to see what you get. Right? Let's start with the top equation. Change x to 1. Change y to 1. I'm going to put a question mark because we don't know if that equals 20. That's what we're hoping, but we're going to see what happens. What's 6 times 1? 6. Plus, what's 14 times 1? 14. Does it look like those are different colors a little bit?
Yeah.
It's kind of weird. And 6 plus 14 gives me 20. And on the right side I had 20. So does 20 equal 20? Yeah. So that means it works in the top one. We also have to check and make sure it works in the bottom. So we're going to fill in 1 again for 8, or I'm sorry, 1 for x. We're going to fill in 1 for y. And the question is, does that come out to 6? What's 8 times 1?
8.
That's 8. And 8 plus 1 is how much? Does 9 equal 6? No. So what that means is if you try to plug in 1, 1, it doesn't work. It works in the top one. It doesn't work in the bottom one. It has to work in both. So you'd click no, and then click submit, and you got it right. All right, so let's look at this one. So there are different kinds of graphs, different ways you can represent data. This particular one is called a bar graph. It's a bar graph. And it's comparing the prices of 2 different items, couches and tables, at 4 different furniture stores. What a couch costs and what a table costs. So it says, does a couch cost less at Furniture Hut or at Wendy's Furniture? So first thing is they're asking about a couch. What color are the couches in this bar graph? Yeah, they're like the bluish, greenish, teal color one. All right, they're not the light purple colors. Okay, so we're going to be looking at that light greenish kind of color, and we're looking at Furniture Hut and Wendy's Furniture. Okay, so here's the data for Furniture Hut, right there, and here it is for Wendy's Furniture. And they want to know, does the couch cost less at which furniture store?
Wendy's.
Yeah, so we're just looking at it. Wendy's Furniture, couches are 70. At Furniture Hut, they're 80, so they're cheaper at Wendy's furniture. And that's it. So let's try to put our answer in, see what we did. Perfect. Okay, so you might see different kinds of graphs: bar graphs, line graphs, and histograms. Let's see if I can get a line graph or something different. Okay, this is a lot of bar graph ones. That's okay. No. Let's try this one. It says, Sports Network displayed the number of Olympic medals won. How many medals did Italy earn in 1976?
15.
Yeah, so Italy is over on the right. 1976 is the orange color, and they earned 15. So yeah, you're just looking at different kinds of graphs. Perfect. Okay, so the next IXL looks at what's called a box and whisker plot. So in a box and whisker plot, it's broken up into 4 sections. So you've got this first section, second section, third section, and the fourth section. The ends of the box and whisker plot, those are what we call the extremes, the lowest value and the highest value of all the numbers that you're making a plot for. How about this line right in the middle? Does anybody know what that line is? In a box and whisker plot? Well, that line, that's called the median. So the median is not the same as the average, like the mean. The median is when you take a bunch of numbers, you put them in order. So you had this. And then you pick the one in the middle. So for this data set, the median is 12. That's the number that's in the middle when you put them in order, lowest to highest. Does anybody know if you had a set of numbers like this? Oops. When there's an even amount, there isn't one in the middle. So does anybody know how you get the median there? Yeah? Yeah, here's where you have to average the 2 in the middle. So you'd add those together. 13 plus 23 is 36. And then you divide by 2. So it would be 18. Okay, so let's see if we can look at this one. Okay, so they want to know the lower quartile. Okay, so all you have to know for that is that the lower quartile is the left edge of your box. What number does it look like the left edge is at? 70, yep. That would be the lower quartile of the amount of time this person practiced their trombone each day, 70 minutes. Let's try another one like that. Okay, it says that the coach recorded the number of goals the hockey team scored. What was the most goals that the team ever scored in a game? So that's an extreme value. It's like the highest, which was how much? 8. Yep. That's right on the right-hand side. That's the most that you've ever scored in a game. Yep. Okay. So those are box and whisker plots. All right, so next, I think the next 2 IXLs, they both look at solving equations. This one has parentheses with a number in front. Does anybody remember the name of the property when you have a number in front and you have to multiply it out? Yep, distributive. So this is just practicing the distributive property. What's 3 times W? 3W, good. And what's 3 times negative 5? Negative 5. I think the more I write, the more it changes color. It's kind of weird.
Wait, what would be negative 5?
Negative 15. Sorry. So 3W, and then 3 times negative 5 is negative 15. Don't forget the minus 8. Nothing happens to it. It just stays right where it is. I was too fascinated by the color changing. Okay, we do have some like terms on the right side. What 2 numbers can I combine together?
Negative 15.
Yep, so negative 15 and negative 8. And if you take negative 15 and subtract 8, That's going to give you negative 20, negative 23. Okay. What would be my next step if I'm trying to get W by itself there?
Add 23 to both sides.
Yep. So add the 23 to both sides. That's gone. What's negative 2 plus 23? 21. And your last step to get W alone. Yep. Divided by 3. And what's 21 divided by 3? 7. Perfect. And then you click submit. So that IXL reviews the distributive property. And the last IXL, that one, is multi-step equations. So it's kind of like they're guiding you through the problem, and they just want you to fill in the boxes, but it's basically what we just did. But they help you do it. Okay. If you did the distributive property, and you multiplied the 8 to what's in the parentheses there, what would you get when you do 8 times 2? Yeah. You get 16. So what you'd have to do is just put a 16 in that box. And they even tell you which property to use. Okay, next property says subtract 6D from both sides. Okay. If you're not sure, you can do it off to the side, just like I am. You can just write, on your screen. So you got 8D plus 16 equals 6D plus 20. Okay. Subtract 6D from both sides. That's gone. What's 8D minus 16? 8D minus 16.
Negative
3D.
What's 8 minus 6? 2. With what letter?
D.
D, yeah. So in that box you would put 2D. Now in the next step they say subtract 16 from both sides. Let's just do it right here. If you subtract 16 on the left, that's gone. What's 20 minus 16?
4.
4. So you put a 4 in that box. And now it says to divide both sides by 2. 2. Yep. So that's just kind of a basic review on solving multi-step equations. But they guide you through each step. Okay. So that covers all the different topics for this week. So just kind of reviewing a lot of different stuff to get ready for MCAS. Okay, so this week, all you have is the IXLs. There's no diagnostics, there's no worksheet, there's no MCAS questions. Okay, just IXLs.
Mr. Hager?